Watching. Today I'm working more on my advanced stock market model in Python. I'm going to go over real quick the progress I've made, what I still need to do, and what I'm going to be working on today. So just to overview, here are my goals for the model. So the first goal is to beat the S&P 500 by a significant margin in all regimes. So I don't want something that works well in bull markets but fails in bear markets. Similarly, I don't want something that performs the same as the S&P 500. I want to beat the hell out of the S&P 500, get way better returns. Once I have that, I'm going to create a usable Python tool. This is my second goal really, is create a usable Python tool so anyone can create advanced models for themselves. So that said, this is the GitHub repository where I'm updating the tool. I organized everything into a really nice clean code base, and you can see that I'm updating this every day as I make changes to the model. So please go download this. Let me know how it works and give me some suggestions on what would be useful to add. Also, star the repository, watch the repository, and follow me on GitHub. All of those things really help me out a lot. And of course, don't forget to subscribe. So those are my two goals I'm working on. This is the outline for the strategy. So I have data. Once I have that data, I want to isolate a universe of stocks. I don't want to include everything. I don't want to include stocks that have low volume or penny stocks. Those are just going to mess up the model and it's going to learn the wrong things. So the first step is isolating a universe of stocks. Once I have that, I want to use that data to train a returns model. And the returns model, I'm looking at certain metrics, really the information coefficient's the key one. I want to get an information coefficient above 0.01. And once I have that, I know I'll have a good model. And then once I have a good returns model working, I'm going to work on a portfolio model, which will allocate the money that I give it based on what the returns model is giving. So what else? So that's basically the outline for the model and what I'm going to be working on. Originally I started this project at the end of December, so this is kind of the progress I made over the first month. I had this by the end of January. I started out getting data from the NASDAQ. It turned out that this isn't it's a reliable data source, but it's not easy to automate. I need to download a new CSV file for every single day. That's really cumbersome. It's going to take a really long time. Instead, I found this better data set, which is available. The link is in the description, or if you go to the GitHub, which is also in the description, I give instructions on how to install this data and get it onto your computer. So this data didn't account for splits, so I had to do some stuff to clean the data, but that was pretty easy. Once I had that, I looked at some different basic analyses, and so this is really a qualitative analysis. Here in the black plot, I'm looking at fundamental variables. And then right here, I'm looking at performance against average. I made some functions that can plot. You just feed it the stocks that you want to look at, and then it'll give you the performance against the average of those stocks. And so this is an example for the pharmaceutical sector. I built the... so the next thing is, since this is qualitative analysis, it's cool to look at, but it's not really easy to automate. So the next step is getting a quantitative model. So I trained a light gradient boosting method on the data. The best I was able to achieve was about 51.5% directional accuracy. I did find some portfolio strategies that worked with this. So if I'm looking at the bottom end number of volatility stocks per day, or if I'm picking those, if I'm picking 500, it's underperforming the S&P 500. If I do 100, it basically matches the performance of the S&P 500. If I do 20, I'm beating the S&P 500, and if I do 1, I'm beating the S&P 500 by a significant margin. Good morning, G Spider. How are you? What are you up to today? This looks like it's a good strategy on the surface, but if you look here at the Sharpe ratios, depending on how many stocks I'm picking, we want a Sharpe ratio above 1 for the model to be considered useful, but the only method that's getting a Sharpe ratio above 1 is if I'm picking one stock per day. And so this kind of indicates that it's fragile. Also, I tried thresholding this. So baseline, it's threshold on 0.5. This is probability of going up. If I increased the threshold to 51% probability of going up, that didn't really improve anything at all. If I then increased it to 52% probability of going up, same thing, barely an increase. But then when I increased it to 53, I got a big jump. When I increased it to 54, it got a big jump. And so you might be wondering, why don't you implement this method at 54% threshold? Well, the problem is if I increase the threshold to 55%, it's not making any picks. And so that also indicates this is a fragile technique. So it looks fragile on two metrics. I want something really robust and not this. So I knew the next step was I had to improve the model, and I basically wanted to rapidly iterate through different targets, features, universes, and methods of training the model and methods of implementing the portfolio. In order to do that, I needed to clean up the code base because it was a big mess. I needed to write a new script every time I wanted to get the universe differently, every time I wanted to change how the model trains, and every time I wanted to incorporate a different portfolio strategy. So I was already at dozens of files. This was quickly going to blow up into hundreds of files, and it wasn't going to be usable for me. And remember, the second goal here is it wasn't going to be usable for anyone else. So in order to stay in line with the second goal and also make my research process faster, I reorganized the code base into just a really clean kind of setup. And so I made some filters for the universe. I already had clean data, fed this into a universe class that then gets the universe easily, so you can easily define your universe. Basically, all you have to do is define the filters you want, and then it'll get your universe for you from the data. I'm then feeding that into a returns model to train it, and the returns model is using feature and target classes. That's really what took so long. These are all the targets and features that I incorporated in green. Magenta ones are ones I wasn't able to incorporate. And so this, I finished this at the end of February. And so the next step was go through, and like I said, I wanted to rapidly iterate on the model. So the first thing was add all features to the model. I didn't really find improvement. I looked through all sorts of different methods of improving the model. This is kind of interesting. I found it does better without ETFs than it does with ETFs. The big thing I found is that, this is also a really good finding, is that if I'm looking out just at trying to get log returns for a day, I couldn't really get it to perform really well. But if I increase that target further out in the future, the longer into the future it's trying to predict, the better that it performs. And so that was my first really good finding here. Another thing I found is that I don't want to look at the directional accuracy, and actually if I'm normalizing the target data, and so I actually don't want directional accuracy at all. Rather, I want these other metrics, the information coefficient, the ratio of the information coefficient to information, and the t-statistic. Oh, and the standard deviation of the information coefficient. So information coefficient should be above 0.01. The ratio of the information coefficient to information should be above 0.02. The standard deviation of the information coefficient, I don't have a metric on that, but I would like that to be as small as possible. And so this is all the improvements that I'm trying to incorporate currently into the model. I looked at lots of different things, different neutralization techniques, different features, and I arrived at this model, which was really good. And so, like I said, if you remember the metrics that I just said I wanted, the mean rank I see, so the information coefficient is 0.02, so well above the threshold I'm looking for. The standard deviation of the information coefficient is about 5 times larger than the information coefficient. And so I would like to minimize that. But if you look here, I found a paper showing historical studies, and it gives the information coefficient of their results and also the standard deviation of the information coefficient. The standard deviation is always larger than the information coefficient itself. And that's because stock market data is really noisy. There's a really low signal to noise ratio. And so this basically shows the standard deviation could be larger. And in these studies that it looked at, it's always 3 times larger to 1.1 times larger. And so, 3 times larger to, I think it was 12 times larger. And so if you look at the Standard deviation I have here 5 times larger, really probably more closer to like 4.5. That's not bad. So also, if you look at the information coefficient to information ratio, I wanted 0.02, and I'm getting that. On an annualized basis, I'm getting 1.583. I'm not sure. Oh, this should be above 0.3. And so you see 1.5, that's way above. So this is really good. T statistic should be above 1.96, and I'm getting 2.3. So this is a really good result. I'm hitting basically every metric I want. And so now I'm looking through and seeing, can I improve this model even more? And if I can improve it, great. Then I'll be even more confident in it. If I do a ruthless, robust analysis on this and I'm not able to improve it at all, then I'll be confident that this is kind of the best model that I can achieve. So I've tried all sorts of things. Now I'm working on removing correlated features. So I'm trying to trim the features down to just the features that are absolutely essential. And so I've tried different methods of this. So if I drop features with this automated method, basically find pairs of correlated features and drop the one that has the highest average correlation to the rest of the data set, this performs worse. Then I looked at if I do that technique that I just said, but then stop the light gradient boosting method from dropping features. This is kind of a like one of the characteristics of the light gradient boosting method is that it randomly drops features as it's optimizing the hyperparameters. And so if I say don't drop any features, does that improve it since I'm already trimming the features with this algorithm? And that made it perform worse. It's actually performing worse than just dropping the features. And finally, I tried to raise the correlation percentage that it's dropping. So here it's dropping 0.75, so 75%. If it's over 75% correlated, it's going to drop one of the features. I increased that, and again, that performs worse. I tried principal component analysis reduction. So this is basically finding groups of correlated features and synthesizing them into a single feature. And so I wanted to see, does this improve the performance? And it actually made it a lot worse. Now I'm looking at going through, I got a list of all the highly correlated features from the model, and I'm trying to drop one at a time and seeing if I drop any of them, does this improve the model? And if it does, then I'll basically conclude I want to drop the feature. And so far I've looked at, how many are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've dropped 6 out of 11 features, and I haven't found any improvement in the model. And so I'm going to continue dropping features here to see if it improves. I also tried this other method, so shadow feature reduction. It creates a shadow feature for each feature, and then it basically jumbles up the data so that it's not in time series format anymore, and that's going to give just random noise for that feature. And then it's dropping whatever features have the random noise feature that performs the best. If there's any features that perform worse than that, I'm going to drop them. And so I did this strategy, but once again, it was performing a lot better than the other feature reduction methods, but it was still performing worse than the model that didn't drop any features. And so today I'm going to go through this, and I'm going to try dropping the rest of these variables. And then the other thing, this is going to take a while because I need to run the model once for every variable. And so once I finish, or while I'm working on this, while the model's running, I'm also going to work on incorporating fundamental features into the model, because right now I only have features from price data. So I want to add some features from the reports too. So that's what I'm going to be working on. That means I've discussed everything. It's time to get down to business. Let me put a comment in the chat real quick. And let's start. Okay, and I'm going to put some music on. What the hell? Oh, my phone died. Good timing. Okay. So, let me pull up my terminal because I think I actually might have run the last one. So this is test model 12, and what am I dropping? I'm dropping EMA. So is this EMA? So IC is 0.0228. Oh, all right. So I already added that. So let me go through now. So we dropped EMA. Now let's drop log ATR. So let's bring that back. Now we'll drop this guy and save it, and let's run it. Okay, so how does this perform? So IC is 0.0228. So you see the information coefficient is still worse than all features, but this is just barely worse. So let's see if it improves anything. Standard deviation of the information is 0.1161. So that's worse. Information coefficient to information is 0.1964. So that's worse. The annual version of that is 1.3943. That is also worse. And then T statistic is 2.041, which is also worse. So we can conclude that dropping the exponential moving average is not improving the model. So let's put the rest of these in here to this table. B bands, stochastic oscillator, and volatility. Move this guy up a little bit so it fits. All right, so let me make sure that's running. All right, so this is running. So now I want to add fundamental features. So let me pull up the data set. What the hell? Okay, so here's the data. This is kind of going to be too much. Maybe I could just send it the link. Oh, okay. Which includes information I included. So I'll say I have access to all information in the database here. Now give me a list of features. Okay, because I incorporated the features earlier, but what? I forgot. What's the problem? Oh, I only have like 2 features, so I want to add every single feature I could possibly want. Earnings yield. Okay. Wow, this is a lot of features. Quarter 1 report covers January 1st to March 31st. The quarter end date is March 30th. Oh, yeah, of course. I only get it on the date that it's reported. Okay, so let's add, where should I put this? I guess I could put it after my to-dos. So let's say fundamental features to incorporate. And we want to list everything that we could possibly want. So same thing as I did for the price data features. Before I'm doing the exploration of the model, let me add every possible feature that I could want. Earnings yield, forward earnings yield, book to market, book to market. We want tangible book to market. We want sales to price. We want cash yield. We want return on equity. We want return on assets. Okay, so the model ran. Here's the feature importance. And here's the results. Now that actually is the best I've achieved so far if you look at this plot. The cumulative alpha is getting up over above 50, and so that's not been happening when I drop a feature. So let's see how that performed. I need to know now. Oh, I don't want, I could just crop it out. Crop out that bottom line. Okay. So that's log ATR. Now let's drop B bands. Here it is. All right, save. Now let's run that. Okay, and then let me document how this does. So information coefficient, whoa, 0.0234. That improved it, didn't it? Yeah, wow, it's the first thing to improve it. All right, how's the standard deviation? That's actually worse. Okay, so it's not better on every metric. ICIR is 0.2042. That's worse. Annualized is 1.45. This is also worse. T-statistic is 2.1226. So that's worse, but I did raise the information coefficient. So kind of the next question there is, what do I do? Do I incorporate, you know, if it raises the information coefficient, which is my main target, but makes every other metric worse, what conclusion do I draw? Okay, so that's something to ask this guy. I found that dropping log ATR from ATR from my model improved the information coefficient, but gave a worse standard deviation of the information coefficient, a worse IC-IR, and a worse T-statistic. What is the cause of this? What conclusions can I draw? And should I drop this feature or keep it in? Question. All right, so let's see. What's it say about this? I need to know now. Know now. Can you love me again? All right, so let's see what it says. Classic dilemma. You've encountered the difference between magnitude of an edge and the consistency of an edge. You should keep it. So Higher mean IC at the expense of your ICIR and T statistic is one of the best ways to build one that looks great on paper but blows up. Log ATR is a measure of volatility. Volatility features rarely act as primary alpha generators. Instead, they act as regime filters or risk scalers. Oh, okay. So when I dropped it, okay. Most important conclusion you can draw from this experiment is how to evaluate your model metrics properly. Mean IC is just gross return. Okay, T-statistic is your proof. A worsening T-statistic means your model's predictive power is becoming less statistically significant. Okay. So T-statistic is really important. Ugh, I have a kink in my neck. Alright, so this guy is about to finish. Got the features. I'm not showing the plots. Oh, actually, I am going to show this plot because that looks really nice. It's going way above 50. And look, these guys are flat in the middle. So really kind of nothing. And these are really extreme. So that looks better than the other thing I was looking at. So that looks really nice. How did it do? 0.0212 information coefficients worse. Standard deviations worse. I think these are worse. T statistics worse. So everything's worse, although it looked good. So let's put this into the PowerPoint. Okay, so that was removing B-bands. Now we want to remove the stochastic oscillator. B-bands, are they in? Yep. All right, so let's run this again. Bollinger Bands. Okay, we've got those two guys. Gonna have to figure out where else do I add the stuff. So I need to add 2 more features in here. So I don't really need to look at these that much. I just need to document them. I need to know now. Know now. Can you love me again? Oops. Where do I put this? Okay, we can move all of this stuff down just a little bit. Let's make this smaller. I need to know now. Know now. Can you love me again? That's good. Okay, now let's move all of this stuff up. Okay, I think I'll be able to fit that in the bottom now. And I guess we could just make the table bigger. I need to know now. Know now. Can you love me again? Okay, so I'm almost done with this. So let's go back to writing down all the features I want. Okay, so return on equity. Here we'll say valuation features price plus fundamental. I need to know now. Okay, so here's the performance of all the features. This is how the model performs, so I guess it doesn't really look that much better. Let's look at the results. Okay, so that's stochastic oscillator. Finally, let's remove volatility. Is that a feature volatility? Bring this guy back. Let me look back at this. So the highly correlated features. I need to know volatility. Here we go. So let's remove this guy. Save. Did I add back in the stochastic oscillator? I did. So let's run it. Okay, then how did this do? So IC is 0.0239. So once again, it's better. Oh, I didn't add the B bands. Oh, well, this is interesting. So 0.0239, I increased the information coefficient. standard deviation 0.104, 1094. So the standard deviation is slightly worse, but I improved the information coefficient. ICIR 0.218. Oh, so that's worse. It looks like we're going to have the same thing as log ATR. Annualized 1.5479, again worse. And then T statistic 2.2658, again worse. So it's the same thing as ATR. I improved the information coefficient, but I worsened the standard deviation of the information coefficient. I worsened the ratio of information coefficient to information, both on a daily and annual basis, and I worsened the T statistic. So although it's giving better absolute returns, it's a less reliable model. So that's not something I want to use. B bands 0.0212. Information coefficient standard deviation 0.1266. ICIR daily is 0.168. Yearly is 1.191. And then T statistic 1.7434. So worse on every metric. Okay, log ATR, B bands, stochastic, oscillator. I guess I'll just have to make that small. Oh no. Cool. And then this guy, trial 21. So this is almost done. I'm almost done with this analysis. So let's go back to the list of fundamental features. Return on equity. Return on assets. Gross margin. Operating margin. Asset turnover. Cash flow return on assets. Okay. Let's give this guy some columns so it fits. Cash flow ROA. Okay, next is this. So here's the feature analysis for that one. Here's the results. It's just barely above 50, so I think this is going to end up performing worse. But let's see. I've got to know now. Oh, that goes down here. So got that, got volatility. .021, so it's a little bit worse on the information coefficient. Standard deviation, 0.1248, so that's worse. ICIR daily, 0.1687, worse. Annual ICIR, 1.1979. And T statistic, 1.7535. So worse on every metric. Okay, so real quick, let me go through. So dimensionality reduction, worsened model performance. PCA, worsened model performance. Single feature removal. Removing any of the highly correlated features. Worsened performance. Two features, log ATR and stochastic oscillator. Improved the information coefficient, but worsened every other feature, and then every other feature. And we could say this means, I guess I'll put that there, and then I'll say this means the model sacrificed. Oh, seriously? Oh no. That's why I can't, that's why there's no viewers. Hey, thanks for commenting that. Because yeah, it's been frozen since the stream started, so that's a big bummer. Let me fix that. So add. I can't believe I did that. I was wondering, I was like, why is this getting no viewers? And that's the reason. Okay, God. I can't believe I did that. I've been talking for 40 minutes I've been going and blabbing, and I was like, why is no one watching this? And it's because the damn screen's frozen. So, sorry about that. Thanks a lot, Capistrella. That helped. I feel like an idiot. Let me put my video back on. Okay. Okay. Here we are. So now I'm watching the stream real quick. I just want to make sure that my screen's coming up. Come on. Okay, that looks good. Switch over to, and yeah, okay, we're good. I can't believe I did that. Okay, so now, where was I? I lost where I was. Oh yeah, so this means the model sacrificed stability for higher returns, not an improvement. So I want to increase stability. I would like to increase stability while increasing returns, but if I'm able to increase stability by reducing returns just a little bit, I'd sacrifice a little bit of the returns for better stability. Yeah, I can't believe I did that. So I'm gonna need to, I did this. So this worsened model on every metric. So far I haven't had any luck with feature trimming. I've tried removing correlated features with the approach from this textbook. That made it worse. tried principal component analysis, basically combining metrics, combining correlated. Hey, Open, how are you? Lots of stuff is good. I had a great day yesterday. Last week, did you see the stream where I did this? Because this was a huge huge win for my model. I'm looking at the um, information coefficient, ratio of information coefficient to information, standard deviation of the information coefficient, um, and the t statistic. And so I got this model, which is beating the threshold that I want on every single metric. And so that was a huge result. So now I'm going through and trying to find, if I trim the features at all, is there any method of trimming the features that will improve the performance of the model? So I've gone through and tried all of these. I've removed correlated features with the approach from a textbook. That made things worse. Tried principal component analysis. I think that's what I was in the middle of talking about when I interrupted myself. So this is basically finding correlated features, and rather than dropping them, it's just combining them into a single feature. And so that made everything worse, made it worse on every metric. I tried removing single features one by one here, and I found that removing any of the features worsens the model on every metric, except for the log ATR, which actually improves the information coefficient, and also the stochastic oscillator. Same thing, I'm improving the information coefficient. So on the surface, you might think that's good, but it's also worsening every other metric. And so what that means is that I'm getting higher returns, but I have to sacrifice stability to achieve that. So that's never a trade-off you want to make. So I couldn't find any metric that removing the metric increased the performance. And so, that kind of explains why all these automated methods are performing worse. I also did a shadow feature method. So basically, for each feature, make a shadow feature, and then jumble the values, randomize the values for the shadow feature. And that'll give it a feature that's just pure noise. So the best feature that's pure noise, whichever performs best of those, if any of the features are performing worse than that one, then I drop them. But that actually, once again, made the model worse on every metric. And so I also could try shat pruning and null importance, but honestly, since I'm not able to identify a correlated feature where dropping it improves the performance, I don't think I'm going to go ahead with that. Okay, so I have this model which works really well. The last few streams I've tried almost everything I can to improve it by trimming the features, and I'm not really finding that that's successful at all. And so now I'm trying to incorporate fundamental data into the model. And so basically what I have so far is I'm doing this model and it's only working on price data. And so if I add fundamental data from quarterly reports, the hope is that that will improve the model. So I'm just adding all the features. These are all the price data features. Oh no, not there. This is all the price data features that I have. So I'm kind of doing a similar thing here. Before I go through and explore it, I want to add every possible feature that I can and then start the exploration. So right now I'm just writing down all of the fundamental features that I could possibly want. Okay, so cash flow, ROA. Okay, so now we can go here. Liquidity / solvency, which is from the balance sheet. Okay, so current ratio. We want quick ratio. We want debt to equity. We want asset leverage. We want cash ratio. Okay. Now we want, this section's called earnings. I'll just say advanced quant factors. So we have Sloan's accruals ratio. We have cash flow to net income. We have, okay, so that's it. Fundamental momentum. Quarter over quarter EPS growth. Year over year EPS growth. We want year over year revenue growth. So you don't want quarter over quarter revenue growth because some stocks like airline stocks always spike in the holiday season. Is that right? I don't pay much attention to airline stocks, but I think they spike during the holiday season and drop during the rest of the year. They might spike during summer too. But you know, if it's a bad quarter for the sector, you're going to have negative. So that's going to throw it off. So you only want year over year revenue growth and then total asset growth. Okay. Next we want, let's add some space. Next we want event driven. Event driven. Standardized. Unexpected earnings. We want post earnings PED, which is post earnings announcement drift. We want days to next earnings. So how many days are we from the subsequent earnings report? And days since last earnings. Okay, I'm already doing that. So blah, blah, blah. Okay, so I don't think I really want to go through and talk about what those are. But the question is, do I want to make a new PowerPoint? Because this is going to take up a lot of slides. See, when I was incorporating price features, took up a gajillion slides. This PowerPoint's already at 100 slides, so that'll increase it to like 130. So do I really want to do that? Fundamental. Okay, so that's what I'm thinking about now. I'm going to go to the bathroom really quick, and I'll be right back. And when I come back, I'm going to be incorporating these fundamental features. So I'm not sure how long this is going to take. I'm hoping I can just march through it and get all of them, but we'll see. The first thing I actually have to do is improve the data set. So I'm pulling all of the fundamental data. However, when I do that, oh, hey, buddy. Good boy. Oh yeah, when I do that, I'm not getting all the data. So you see here, I'm getting, I have release date, I have ROIC, operating margin, and days since release, but I don't have anything else. So this is all being saved in a data set because I don't want to have to call the SQL server every time I get the data. I just want to call it once and put it into a data set. The problem is the fundamentals data is going to be big, so I have to figure out, how am I going to do this? You can see the open, high, low, close data is pretty small, all things given, so 600 megabytes. Yeah, so the question is, do I really want to, if this has 4 columns, but to get all of this stuff, this is going to be dozens of columns. If I'm going off each table, there's so many tables here, each one with a bunch of columns. There might be 100 columns, and so that would be like 20x, so 600 gigs times. Oh, but there's also a way. I mean, the fundamental reports happen way less often. So this will be smaller. I just need to. So the days since release and stuff, all that logic should be incorporated into the feature engine. But like I said, I have to go to the bathroom, so I'll be right back. When I come back, I'm going to be working on incorporating these fundamental features in hopes that I'm able to improve the results that I have here. So this model's getting beating the threshold on every metric I want. It looks good when I look at the decile analysis, and the alpha over time is above 50 for cumulative alpha over the training period. So that's all really good. So, yeah, I'll be right back. Hey, thanks for letting Bunny in. And then he got upset and went to bed. Okay, I'm back. Um, so oh, where the hell did my screen go? Just a sec. I have this problem with the HDMI. There we go. I can see it. It never goes away for you guys, but for me, I can only see it if I adjust the HDMI. So, okay, before I get down to business, because this is going to take a while, what I want to do is, put some music on. Locked in Mariah's wine cellar, all I had for lunch was red wine, more bread wine, and Captain Crunch. Okay, so let's do fundamental features. You want to down in the 6. You said I'd probably send you some pics, and I'm like, hell nah. Been waiting too long, I've been waiting. Where is this currently saved? Okay, so let's make a new PowerPoint. Oma sensei. Two ain't wrong, just not incidental. Okay, so um Oma senses. Oma senses. Okay, so let's look at the logic here. So Um, I need to pull a news data set. Hey, Sir Night Night. How are you? Check this out. So I tried all sorts of different feature reductions, and basically every feature reduction failed. Even if I went feature by feature and removed one at a time from the model, that made it worse. Except for log ATR and stochastic oscillator, if I removed those, I improved the information coefficient, but worsened every other metric. So I'm sacrificing performance for stability. Or I'm sacrificing stability to gain a slight increase in performance, which I don't think I want to do. So now I'm going through and adding fundamental features. I have a list of them, and so now I need to improve the data. So should I add everything at once to a new fundamental data set, or should I call the SQL database inside a feature engine? There's a lot of context in that. You mean, which isn't a failure? The fact that no feature trimming improved the model? I'm assuming what that means is if I'm not improving the model by removing any features, then probably I should add more features, was my conclusion. And then the other thing is that, yeah, I don't know. I didn't think it was failure. I think it's just kind of, the conclusion is that I'm not improving model performance by removing anything. Oh, okay. Idempotency, 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 idempotency. What the hell? I've never heard of that word before. Idempotency. Wow. Okay. I learned a new word. Idempotency, idempotency, idempotency. Okay, now I want a data loader. The context of what? Wait, what do you mean? Ask it what the context is? Oh, you mean of the word idempotency? Or what do you mean context of what? I don't want to merge them because the fundamentals were only getting quarterly reports. So there's a ton of columns, but there's not going to be a lot of rows. So I want to merge inside of the... I only want to merge when I'm doing the feature inside of feature engine. What does it mean that none of those feature reductions worked? And the type of feature reductions. Oh, well, I already asked it that, and it says basically that because T statistic gets worse, information coefficient to information ratio gets worse, standard deviation of the information coefficient gets worse. Therefore, you have a less stable model. But since information coefficient's higher, you're getting better returns, basically. Um, I don't want to change this to include rows for every date for which there's price data. Because why? Oh, this will make the data set enormous. Rather, I want to incorporate everything later on inside of feature engine. Okay, so then when I'm incorporating these new features, that's going to be really hard. Because all this logic is for open, high, low, close. So maybe I could call this price feature engine. No, because I'm calling it inside the model. I don't know if I should make a different feature engine for the fundamental features. I just want to include ETFs actually, so I'll delete that. But so feature or data retrieval. Let's put a new script in, which says get fundamental data .py. Don't want to remove ETFs because I can do that. When I'm incorporating it, it just won't incorporate tickers which aren't included in the price data. Are the types of fundamentals you're planning to use? Yes. It's all the stuff in here. And I have this locally on my computer, so all I have to do is, get basically do a SQL call to get whatever I want from whatever any of these. But I think it should be feature. It should be faster if I incorporate the whole feature data set at once and then merge stuff together later inside a feature engine. So let's see how this works. Oh, and where's it saving? So data, all fundamentals, dot feather. Where did the query thing go? So, show earnings tables. It's not in Explorers. Maybe we could find it easier here. What the hell? Oh, I ran it again. Damn it. Uh. I guess I don't need this anymore then. Hey, Mark. Thank you very much. I appreciate it. Helps me out, of course, if you subscribe. If you go to the GitHub, star it, watch it, and follow me on GitHub. And then also join the Discord because I want to talk about interesting stuff in there. But thanks. That comments like that help me keep going. It is a big project, but that's what makes it interesting. Let's see how this works. All right. Before I add too many other things, I want to upload things. All right. Oui. Je m'appelle La Chapelle et je suis français, non? You think we will see a draft with this Iran war? Oh my god. I mean, honestly, if there's a draft, there's going to be riots in the streets, I think. I don't think there's going to be riots in the streets. Trump will get assassinated or impeached. There's no way we're going to have a draft with the Iran war. Honestly, if there's a draft, that will be American Civil War. And will it even be a civil war? Who the fuck supports the war? I hope we don't see a draft. If there is a draft, I don't see any way there's a draft. That seems insane, don't you think? There wasn't a draft with Iraq, and Iraq and Afghanistan didn't have drafts, and those were way more popular than this war. This war is just totally unpopular. I don't see any way there's a draft. And if there's a draft, I'm going to go riot in the streets too. I'm going to join them. I won't riot. I'll go, peacefully riot or whatever, if that's a thing, I don't want to burn anything down, but we can't have a draft, dude. That will be the end of the U.S. What else do I know how to say? Como se va? You say that means how are you doing? You say je suis français et vive en America. How do you say but in French? Pero, you say in Spanish, pero je suis français. Je vis en America. Je suis américain et français. Alright, so the last two errors was because there was a name. What do you think, Sir Night Night? Is there going to be a draft? Where have you heard about people having a draft? I haven't heard that anywhere other than wackos. I hope there's not a draft. Tell me what's the references for that? Where are they talking about having a draft? That's so crazy. My dad was drafted in Vietnam, and he watched on TV. You tune in at night on TV, and you watch the lottery happen. You have a number, and you wait to see if your number's picked. And if your number's picked, there you go, off to Vietnam. The last two errors is because there was a naming mismatch between your code and the Dolt database. You have the link for the Dolt database. Reassess the code to ensure there are no errors before I run it. Rewrite if necessary. Otherwise, explain that. Otherwise, explain your conclusion. End the fuck war? What does that mean? The fuck war? Fuck war sounds scary. I don't want any part of a fuck war. Really. If there's a fuck war, I'm getting the hell out of town. If there's a fuck war, I'm going to move to the mountains. Never heard of a fuck war before, and I don't want to be a part of it. Also, anyway, right now there's 6 viewers, so I'm going to take this opportunity to say please subscribe. Please go to the GitHub. Start the GitHub, watch the GitHub, and follow me on GitHub. All of those things really help me out a lot. And join the Discord so we could have fun conversations about world politics and the stock market and philosophy and science and any ideas generally that are interesting. So right now I'm trying to get fundamental features and incorporate it into my data set. I got a really good result the other night on my stream. This is what it is. And so now I want to go in and, look, I've been looking to see, can I trim the features to improve it? I found that I can't really improve it by trimming the features. So now I'm looking at how can I add fundamental data. I think this is kind of the last thing that I can do, which will really improve the model. The last obvious thing that I have in my head. I also have other to-dos here. What else do I have to do? Add fundamentals. Transform to better residualize target. Oh, so that's something I can do. I did these suggestions. Oh, I need to add the volatility index. I need to trim features to the most robust. Get the model saved to work. Add an assessment class. I'm not sure if I want to do that right now early at all. I need to add so fundamental information will probably improve the model, but also sector information will probably improve the model. Then I need to look through, do I want to do a different model for each sector? Check for overfit bias, risk factors as a metric, define market regimes and split data accordingly. So that's like I want to do a bear model and a bull model. And then also, I need to add interest rates, right? Okay, that's here. Yeah. Save. All right, so let's see if this runs. Every day. I'm done with my monster. I need a new drink. Okay, good. We have it. Let's go look at it. So let's go Python. Earnings calendar.feather. Okay, so import pandas as PD. Calendar is equal to pd.read feather earnings calendar. And let's see how big these are. So are they bigger than the price data? I'm hoping they're not. I don't think they should be. (1.2 megabytes), so that's way smaller. Oh, 55 megabytes. That's also way smaller, so we're good. So now let's look at the data. Earnings calendar dot feather. Let's look at the calendar. Okay, so now we want all fun is equal to pd.read feather all fundamentals dot feather. Sales, cost of goods, gross profit. I mean, this looks good to me. Okay, so we have the fundamentals data. But all existing logic is for will it be practical, not practical, but efficient to incorporate these directly, to incorporate the fundamental features directly into feature engine, or should I add them in a new script? Knees again, looks like I'm on my knees again. Na do 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 do. Okay, I gotta go to the bathroom again, and I'm gonna get a drink while I'm at it. I'll be right back. Okay, I'm back. I've got a coffee. Crap. Shit. I spilled the coffee on my computer. Shit. I hope I didn't fuck anything up. Okay. I'm actually gonna end this stream right now because and go put my computer in rice. And I'll do another stream later tonight. So thanks for watching. Have a good rest of your day. Adios. I'll do another one later and we'll keep working on this. Bye. Okay.